Hello and welcome to Sudoku. Here is a Mathrax Sudoku puzzle that was set by the Dutch author Arvid Baars. I'm not sure about how it's supposed to be pronounced. I did my best. And it was featured on the 2016 Sudoku Grand Prix in round 1. And it looks like there's a Netherlands round every year, and that's all for the best because the Dutch authors are excellent. They're just world class. Okay, so about the rules. Every time you have an operation and a number, the number is the result of the operation applied on the 2 digits on each diagonal. So something minus the other must be 4. Here the difference is 7. Here the sum is 9. Here the product is 16. And here all 4 digits must be odd. And if there had been an E, all digits would have been even. That's a Sudoku variant that I like very much, and I published a video recently on my channel. The video was in French, and some viewers were dissatisfied because they expected a video in English. So I just said, I love Mathrax, why not do a video in English? Okay, where do we start? 12 here. I start with clues that are completely embedded in a 3x3 block. So this 7 has only 2 possibilities. 8 minus 1, 9 minus 2. So all those 4 digits are those ones. And you can see that 1 or 2 wouldn't work here with the 13. So this one has to be 8 or 9. This glitch again. And correspondingly, this is 1 or 2 and 5 or 4. And that is interesting because we now know that this sum of 9 will never be 5 plus 4 because there would be no option for this. And this will interact with that because 16 has to be 4 times 4 or 2 times 8. And you see that both diagonals cannot have the same decomposition. So one of them will be 2 and 8, the other will be 4 and 4. And it means that one of those digits is 4, and this one is not. So that's a 5, that's an 8, and that's a 1. And we get 2 and 9 there. So there's 4 somewhere. Oh, and now we know more. This 8 says that no 8 is here, so an 8 has to go there, and a 2 has to go there. So this one is not a 2, this one is a 2, and 2 can't be there because of this one, so I know that 2 times 8 is on this diagonal, and 4 times 4 on the other diagonal, and I get a 9 here to fulfill this 5 minus clue. And this is a 7. So that's a nice beginning. This 12 now must be 2 times 6 on some diagonal and 3 times 4 on the other diagonal. So all 4 digits here are those ones. And now look at those 8. 8 can only go here in this box. And 4 is in one of those 2 cells, and 3 is there. So here, this is 2, 6, 3, or 4. It's not 4, so it's 2, 3, or 6. And this is interesting. So this is 2, 3, or 6, and correspondingly we get 1, 6, or 3 here. What else can we see? 8 is not here, it's not here, it has to go up there. 8, 8. 8 is in here together with a 1. So there's 8 and 1 here. 4 is not in here because of the 5. So 4 is in one of those two cells. 4, 4, there must be a 4 up there together with an 8. So I just, well, like this, I'm not sure exactly where they go. Here, what is the other sum? It's not 9 plus 4, so it's not 8 plus 5 because there's no square for a 5, so it has to be 6 and 7. Here there seem to be a number of options. 6 minus, it can't be 8 minus 2 because of this. None of those digits would fit here or there. So what remains? 9 minus 3, 7 minus 1. So again, no digit can repeat. If I put a 7 here, then 7 is removed from those cells, so it can't appear on the other diagonal. So we know that those 4 digits are those. Okay, and 9 wouldn't go here, so this is one of the other options. 1, 3 or 7, together with 7, 9 or 1. All seem to work, and here any one of the 4 options seem to work, and here correspondingly we get 8, 6 or 2. Yes, I really like the words correspondingly. And there's a 4 here, but 4 can't go there, so 4 has to go here and there. 4 is not in this odd digit area, so there's a 4 down there. Note that 2 and 6 must also be on the outer rim of this. Now, will there be an interaction between this and that? I wouldn't say. What happens up there? We still need 3, 5, 6 and 7. 3 is not here. So this is 5 or 6, 5, 6, 7. There must be a 3. The beginning was pretty fast, but now it's more difficult. Oh, I didn't consider the second diagonal. It doesn't have a 4. So what remain? The remaining options now are 2 divided by 1 and 3 divided by 6. So the other digits are also among those ones. This is not a 2, so this also has to be 1, 3 or 6 together with 2, 3 or 6 here. Nine is not here, it's not there, so 9 is here on this column. So 9 is not here, that's not a 3. So it was 1 and it is 1 and 7 here. This can't be a 6. And the other diagonal must be 9 minus 3. Oh, actually, this is a 9 by Sudoku. That's a 3, and now this 3 is not here, it has to be there, with a 4 on the other diagonal. So what remains? 2 and 6 here, with 1 and a 3 there. This one can't be 3. It has to be 1, 2, or 6. This can't be 3 either, so this one is a 3. With 6, that's a 2, that's 1 or 2. With 2 or 1. Oh, that's not a 2, so that's a 1, that's a 2. This one gives this 7, and this 1, and this 8, and this 6, and this 7. And this 6 gives 5, 7 up there. Those are 3 and 6, there's a 6 there. And a 1 to complete this column. Here we need 1 and 5. Here we need 3, 5, and 7. And now this 5 minus is very restricted by those digits. We have all four small digits here, so this one must be a big digit, and it can't be 8 or 9, so it has to be 6 or 7, with 1 or 2. And same here. All small digits are here, so for this 9, those must be big digits. There's always a digit between 5 and 8, and a digit between 1 and 4. So the small digits are here, and they are not 1. And this one is not 2 or 3 either, so it has to be a 4, and this is a 5. And then this one will be 2 or 3 with 6 or 7, which is paired with this one. And up there we get an 8-9 pair, but this 9 plus says that 8 goes here with a 1, that's a 9. And this one gives this 2, this 7, this 7, this 6, this 3. That's it. And 7 is not here. 5. This is not digit, and only 9 fits. So this one has to be 5, 1, 3, 7, 9. It has to be a 5. And this one is 1 or 7, and we don't know which one yet. On this row we need 3, 5, and 6. On this row, 1, 3, there's a 1, it's not here, it's there. And the remaining digits are 3, 7, and 9. What can this be? It can't, well, it's not 1 and 8, it's not 4 and 5, and it's not 3 plus 6 because 3's are taken, so it has to be 2 plus 7, and because of those digits we place 2 and 7 this way. And we get a 6. This 7 gives this 5. This 3-9 pair gives this 7, and we get this 3. There's a 5 here, and 6 and 8 there. So we should be close to the end. There's an 8 somewhere, and we know it has to be here. With the 4. And 9, we get a 9 here. This row needs a 3 and a 6. That's a 6, that's a 2. We get this 3, this 5, and a 1 up there. Let's clean up. 4 here, 6 there. And now that's a 6. 8 and 6 down there. Here we need 8 and 5. There's a 5 here. And I think the end should be self-explanatory. Okay, 8 here, 7 there, 7, 2, 2, and 9. Okay. Fine, that was a very well put Mathrax Sudoku puzzle. And it was somewhat challenging, but what I like is that it displayed really all common techniques that you find in Mathrax puzzles, like having globally all digits in a 2x2 squares and using interactions between all possibilities. And for example, using interactions between this and that, or between this and that. That was a very good puzzle. Thanks for watching this video. See you soon on Sudoku.